Thanks a lot, everyone. Thank you for coming to this session. Now, this session is really all demos. We might have a few slides, but it's all demos. So first of all, good afternoon, everyone. Good afternoon. Now, this session is very interesting, right? We got some of the best AI folks within the company, right? And we brought them all together, right? From developer advocates to data scientists to engineers to even folks from marketing, all coming together. And you see all this last minute trying to connect things is because they're all coming. They have shows before and after this, all coming together in order to show you and put together a really nice AI show for you, right? And like many Avengers, when you assemble all these Avengers, right, we are often backed by a really, really talented team of engineers as well as interns. Many of these are based in Vancouver, and therefore we want to give them a round of applause, right, and thanking them for delivering a lot of the shows. Now, and we only have one goal, right? By the time you walk out of this room at 4 p.m., right, we want to make sure that every one of us, right, the developer in us, all of us can do AI, right? And if you can't do AI by the time you leave this room, we have failed, right? And it can give us really bad scores, right? Now, and therefore, before we get started, how do you infuse AI into your application? This is just a quick intro. Take any existing applications that you have or new applications that you're trying to build. You add AI to it. You bring lots of data to it. And of course, you get an AI application. But we realized that as you saw a lot of the demos in this keynote this morning, right, it's not just about data. You really need a tinge of creativity, right? And you need a lot of help from many of the services that's been announced today, right? Whether it's cognitive services, whether it's bringing your own data and building your own models, to even customizing your AI models, right? And therefore, without further ado, I'm going to show you the first demo, which we call Snip Insight. Now, before we get into the demo, just a show of hands, how many of you use the snipping tool? Awesome. Now, and every time there's a Windows update and you try to use the snipping tool, do you wish that, hey, with all these conversations on AI, there must be some AI into it that makes it even more powerful? Right? And that's exactly what we challenged a team from Vancouver to make that happen about 3 months ago. I'm going to show you that. Now, the sample code is all available. And therefore, after this, you can actually use this and continue expanding on it. Right? So let me get into the demo proper. Now, what I'm going to do here is I have already installed Snip Insight, right? I'm going to start off this snipping tool. And you see this little thing on top, right, that has something for you to snip and so on and so forth. And I'm going to go into my browser. And let's search for Harry Potter. Let's take a look at some images there. Now, and you see many, many pictures of Harry Potter. Now, let's just try to do a snip, right? Today, if you use a snipping tool, you probably just snips, and then that's it. You paste it in all your applications. You want the snipping tool to be more powerful than that, right? With all this AI into it, let's see what happens. So let's just take a picture of this guy, whom I don't know who he is. Now, at this point, what is happening is it invokes cognitive services in the back end, and it comes back because of the celebrity recognition. It knows this guy is Daniel Radcliffe. Right? And of course, you can read all the nice news about Daniel. Now, let's continue the demo. Right? Let's suppose we say, well, let's take a look at text. You might be reading some text. You might be reading some ebooks. And sometimes it could be in a language that you do not understand. Right? And therefore, what's going to happen here is I'm going to click on this. And it's just one of the paragraphs from Harry Potter. Let me just snip again. And again, what is happening in the background is it's sending out to all the cognitive services. It realized that this is text. It's using the OCR services. It's going to bring it back. And it essentially performs OCR on it. And for some of us in the audience and it detected it's English, who doesn't speak English, for example, you could have it in Estonian. You could have it in Hindi. Right? You could have it in many, many Malay, or my native tongue, which is Mandarin, or even Cantonese, right? The point here is that with these things infused into the tool, you can do wonderful stuff here. Let's see what else it can do, right? So, well, let's end off this demo by searching for maybe a white shirt, a white T-shirt. as our background, right? So let's take one of these guys here. And let's do a snip of him. And right now, the same thing is happening, but now it's using the Bing product search, right? All these are services that you can already use today, right? There's nothing here that is peculiar to Microsoft. Everything that you see here can be done today. And now I say, well, I don't really just like a white shirt, right? A white shirt is boring. Let's add something to the shirt, right? So let's use the tool, and let's make sure I have my thing here. And let's say I. Let's change the color. Love. Sorry for my horrible drawing. Let's color this a bit. And you can see my hands trembling. And let's say, I love AI. Now, let me try refreshing insights. And what is going to happen right now is it's going to add all these things that I've added to it. And it's going to do a product search. And it's going to find other kinds of shirt that's similar to this. And wow, awesome. You get, I love different kinds of shirt. Feel free to click on one of them and buy them, right? Now, and of course, this tool is much more than that. And the source code is all available. All you need in order to get to a tool like this, right, is cognitive service, a tinge of creativity, as well as AI, right? So let's switch back to the slides. Now, a good news is not only the source code is available, today, just at about 2:45, the Garage team has also made the tool available for download. And therefore, if you download this, you'll get exactly the same app that I've shown you, right? Awesome. Thank you. Now, the next demo we're going to show you, right, comes from one of our engineers. And he spent a lot of time at conferences. You know, every time we sit in an audience like this, I remember when I first attended a technical conference, I'm not a native English speaker, as you can see. I feel shy. I would never dare to ask any questions, right? And I just wish, after I leave the room, I should have asked that question, right? Now, Wilson is going to come out on stage, and he's going to show us, well, for all of us that's very shy in the audience, do not worry, right? He's going to show you, with cognitive services and board, how you can build a conference buddy that's going to be your best friend. And I'm going to hand it over to Wilson.
Can you guys hear me? Great. Awesome. Now imagine a world where you are an audience member in a conference session just like this one, right? That you can ask any question to the speaker at any time. Wouldn't that be great? Just like what Wee-Hong says, now, I'm just like you guys, right? I attend many different technology conferences and keynotes. And I remember just like, for example, just like this morning during Satya keynote, I was sitting there in a large hall surrounded by thousands of other attendees. And I was listening Satya's talking about the ethics of AI or the exciting announcement of Azure Sphere. And I started to have a running list of questions that I want to ask. Right? And maybe because I'm passionate, I just want to learn more. But for whatever reason, it's never a good time for me to ask my questions. Okay? Maybe it's not the right Q&A time, or maybe there isn't one at all, just like most keynotes, right? Or even like even the Q&A session is available, I'm a little shy, you know. I don't want to go in front of a microphone, standing in front of thousands of people and ask my questions myself. Or maybe that once I can conquer my fear and actually go to a microphone, I just realized that, oh man, I just forgot all my questions sometimes. And sometimes that maybe because the line is too long, you know what, it's not my turn. So we're wondering, since Satya was mentioning this morning to get AI into the hands of developers, I'm a developer, I like AI. So I wonder if I can actually gather several ingredients from our Azure Cloud AI platform to help me, myself, and others to actually able to ask questions more effectively. Okay. So this is why I'm very excited to talk to you about the Conference Buddy, right? Conference Buddy is a concept that we have built to showcase how to take few ingredients from the cognitive service and integrate them into the bot service and provide a solution to make asking questions more effective. For Conference Buddy, we'll discuss the overall architecture, And then we're going to dive into some code to understand, some of the roles that there is in there. And I'm going to show you how to add new capabilities to the solution. All right. There you go. Oh, I can use this. There you go. All right. So let's first start with the architecture, right? So the conference buddy is built based on a microservice architecture. Okay? This means that each component is responsible for a single workload. They are each deployed individually, and thus each component can be scaled and tested individually. Right? As you may have noticed, Conference Buddy consists of 3 components. We have the conference bot, who is dealing with messages from the users who are sending and receiving messages. Then we also have the bot brain, who actually handles the message that are coming from the bot itself. And then we also have the dashboard, which is down over there, that you can see that is actually displaying all the messages that are stored in our Azure search. Okay? And also, you remember that I was talking about that each component is actually responsible for their own single workload. So what happened is that the conference bot doesn't care about all the cognitive service. For example, we've shown here the text analytics and all that. All it cares about is to get the message and also send the message out and format it correctly. It actually talks to the bot brain through an abstraction layer, which the bot brain itself, it's actually Azure Functions, where each of the tasks itself are actually independent and they don't impact on each other. Then, of course, as you can see on the dashboard itself, it actually doesn't even talk to the bot brain or even the bot itself. It actually grabs all the data from Azure Search. So with that, let's take a look at the code and of how all this works and what do I all mean by all that. All right, so let's switch back to the code. Back. All right. Let me bring up the code and what I meant by all these segregations. So let's take a look at the bot code we have here. So this is a standard bot code that you might see. Basically, you start a sync and you're actually getting messages. Once you get messages, basically all you do is that, okay, so you massage the message, and you actually do some trickery to actually, for some of the channels that you might need to, filter some words when you have a group chat and those kind of things. And then you call Luis to determine its intent, okay? So what kind of intent it is. And then you process the intent, okay? Apart from Luis, as you can see, there's no code talking to any other cognitive service itself. Then what it does is that it tries to process the intent and try to create a data contract, which is the abstraction layer that I was talking about, right? So we actually formulate the request with all these information, and then this is the step, which it's actually sending to the bot brain itself, okay? So what happened is that it called an HTTP post and sent it to the bot brain, which is an Azure function, and tell it that, hey, I need something from you. Give me the answer that I understand, and that's all I care about. And then the rest of the code is really massaging the message and format it so that it actually looks great on the user side. Now, I keep talking about the abstraction layer and all that. But basically what that is basically a data contract, okay? So this data contract, for example, this is ask question request, which fills in all this information that only the bot brain understands, the bot and the bot brain understands. Then what happens is that the bot brain will come back with another data contract, which is a property bag, that actually contains all the response to answer the user's questions and coming back with all the processing that you might want to do. Then we have here, which is the Azure function itself, which is the project right here. And you can see that this is a very standard Azure function, right? Everything that comes in is just processed to see if it's the right type and all that. And then at the end, it actually trying to answer the question. Or in this case, it's more like the passing the questions to the speaker. So what all it does is that it captures the timestamp. It actually trying to run key phrases on that. So that you can determine some topics and those kind of things. And then what happened is that it immediately sent to the Azure Search as a backend, so the dashboard can actually see it and process it. Okay? So that's how this works. So what I'm trying to do here is that, most presenter, what they do is that, okay, well, I've shown you code, I've shown you architecture. The next step, what it would be? I'm going to press F5 and see if it'll run, right? But I want to do something a little different today. I'm feeling a little lucky today, see if it works. So I just deployed this solution probably a couple minutes ago before the session. And I wonder if you guys can actually help me test it out and see if it works, okay? But before we go to that, I want to ask a question. how many for the folks in here, how many of you is your first build conference today? Oh, wow, majority of you. All right, sounds good. Who is the second time that they're here, or twice? Okay, a few. 3 times or more? Wow, you guys must have loved build, or you guys are a really, really good speaker in here. So how about that? Now, let's test this out. Please take out your phone, or you can use your laptop if you have that. Go to aka.ms, whack build demo chat. And what you see on that, it's actually a web chat that you can now send in and let me know what is your favorite moment in build. And we try to see if we can actually populate the entire dashboard as quick as we can. So it's aka.ms build demo chat. If anyone has a problem, let me know. All right, so let's see. Switch it back to this. And then you will see, this is the, and then you see a chat, web chat here like that. And you can actually send. All right. All right, so what we have here, we have 5 questions so far, 10. Wow, that's really, really fast. Ooh, people love the cookie at lunch. Oh, that's amazing. Well, I wonder what type of cookie would that be. All right. Ooh, someone don't like the lunch. I wonder if someone took their cookies. I wonder if that's why. Yeah, there you go. All right, so the lunch is great. So you can see that what happens here is that as you guys are sending in all your comments about the things that you like about build, or in a session like this, you will send in questions about the things that you want to ask. The presenter itself can actually take a tablet or even a laptop like this, and they can actually see all these things. And you remember that I talked about that we actually perform key phrase extraction on there? Because of that and Azure Search, now we can actually filter all these questions by topic, and it's actually going very, very quickly. So for example, let's see if we can find the cookie. Oh, there you go. Oh, there's one L cookie here. And there you go. See, we can actually filter it, and actually we can see the cookies. Or maybe we'll say, all right, so let's see if there's anything else. Let me search for all the comments that someone says about cookies. All right, we got someone who likes peanut butter cookie. That's awesome. So let me recap what you guys just did. You guys just tested a proof of concept that we just deployed a couple minutes ago, and you guys helped me out to test this. So thank you. Give yourself an applause. Thank you. Thank you so much. I've never done this before, but I'm very happy that it didn't crash or didn't fail. So I'm very happy about this. So now, what's next? What else can we do? Okay. It's great that we covered this scenario, but I'm a developer. Man, I want to do more. Can I actually add more things to that? Okay. Think about that before the conference. Okay. Before the conference, people might have a lot of questions as well. So think about when you're actually building your schedule, on your phone or on the app itself, you're building a schedule. You saw a session, okay, Demopalooza. You want to learn a little bit more about it. What if we actually can provide in this solution itself, in Conference Buddy itself, can actually provide you with a solution that you can ask questions to the Conference Buddy bot itself, and actually provide you with video that actually talk about something that's related to the session itself. So what happened is that what we can do is that we can introduce a new task that we add to the bot brain itself that actually talks to video indexer. Well, let's give it a try. Okay. So let me switch back to the code. All right, we're in here. And then you'll see that this is the bot brain solution. Okay, we have the ask question task that you guys all tested. Thank you for that. And then what we can do is that, all right, so let's add another task that we talked about. Oh, there you go. Okay, this got moved. All right, so let's do that. Okay, bot brain. All right, there you go. So ask learn more tasks. Okay. Ooh. All right. Okay, so what happened here? It's a little malfunction here. I wonder what happened. All right. Let's see if the second times is a charm. Right here. Nope. Cannot find path. All right. All right. Okay. So basically what we're trying to see here is that we can actually have this deployed. And then what happened is that it actually goes to the service called Video Indexer. So what Video Indexer is that it actually capable of you can actually upload all the relevant video that you want. And then what happened is that this service, this cognitive service, will actually grab the video, analyze it, parse out all the different texts in here. And then, let me see. And then what happened is that it can actually extract a transcript, and actually they actually provide you with an endpoint that you can actually search on this. Now, let's see if I can actually show you a demo without the code itself. Let's see if I can actually make this happen. All right. Okay, there you go. So let me make the bot as the project. Let's run F5 this time. Hopefully this time it runs. Oh, what happened? Okay. Oh. Okay. This used to work before. All right. This actually used to work before. All right. So what I'm trying to demo here that it wasn't working at the moment is the fact that it actually could. What happened is that we can actually create a new task, and actually with that task, actually goes to Video Indexer and actually search for something. So for example, if I said that I want to learn more about the power of AI, and what happened is that it actually comes back with the URL and with the timestamp. And I can actually show you a result of what kind of things it could be. So for example, in here, I've already loaded that. You'll see that this actually saying that, okay, so this actually has the URL in there and actually have a timestamp. And if I actually reload this, and then once display, and you will hear, let's see if that works. Come on.
Well, with the power of AI,
see? My question was, I want to learn more about Power AI. I send it in as a query. It actually comes back with the exact moment when in the video itself is actually talking about this topic. So with that, then you can actually learn more about what you want via a video, and you can archive all that and provide your conference member or anyone who wants to learn more about this on topics that are actually relevant to their question itself. Isn't that cool? I think that's actually pretty awesome. Now, I was prepared to actually show more about the bot and things like that, but something happened that this is not compiling at all. So then I can run the bot itself, but what we can do is that, see if I can do something like this. Okay, let me see if this will work. All right, that's good. So what I've done is that I go to my conference buddy bot that you've seen before, and let's see if that I can actually repro what I've shown you guys before. So for example, I said that I want to learn more about the power of AI. All right, there you go. Then let's see if it comes back, and there you go. So this is the, even the images is not working today. Okay, so that's great. All right. So with that being said, what else can I do? Okay, we talked about pre-conference, right? What about during the conference itself? Can you actually provide some information to your users that can actually help them with the conference? So for example, in the Build conference, we have a code repository of speakers, right? We're talking about, hey, who the speakers are and things like that. Maybe I can actually add a skill set inside the Conference Buddy bot itself that actually can answer this question. So what happens is that we can create a new skills that we call Ask Cool Skills, okay? And then we can actually leverage Q&A Maker, which is a cognitive service that actually allows you to map question and answers. So you can see here, for example, if I ask for who is Joseph Sharosh, and then I actually map all the formatting and the title, the content, and even the, for example, the image that I want to use about Joseph, and I can send it back to the user. And it actually goes through the same pipeline that we've shown you before. So let's see if this actually works, okay? Who is Joseph Sharosh. Okay. I hope this time works. There you go. All right. So this time, OK, sounds good. All right. But then having all this information that you created is one thing. I'm a developer. I love AI. I want to do more. Can I do something like that? What if I can actually get the world's knowledge into this solution itself? Okay? What if we can actually leverage Bing to actually do that? So basically what happened is that we can actually bring in our favorite search engine, Bing, into this solution. And then basically it's just another cognitive service that is called Bing Search, which you can actually go to Azure and actually search for it. And actually you can add that to your deployment itself. So if you go to Azure, you click on the plus sign, and then you can actually see, oh, that got moved as well. All right, so you can actually search for it, called Bing Search. And then you can see that you can actually deploy. Oh, there you go. Bing Search right here. Bing Search V7. You can actually get that and get the ID. And similar way that we actually use the video indexer or the similar way that we did the Q&A maker, then you can actually bring the world's knowledge into your app itself. So I apologize for the demo not always working. So sometimes the demo god are not always with you. I'm glad that you guys are helping me out to test the overall end-to-end scenarios. But hopefully that with this little demo, hopefully I can inspire you guys to actually bring some AI to your solution as well. It's really, truly AI for all developers. All right, thank you.
Now the next demo. Let me just. We started off this session by saying all of us in this room can do AI, right? And therefore, given that of time constraint, I'm going to start timing myself in trying to build an end-to-end AI model, right? Or rather, more specifically, a deep learning model, train it in the cloud with massive GPUs, coming back and then consume it in a .NET application, right? And before we get into that, right, I just want everyone to reflect on something like this. Does this look familiar at home? Right? And while trying to put this demo all together, it's very interesting. It's like just a week before the build conference, every time your young kid is going to run up to you and say, hey, you know what are you doing for a conference? I say, well, I am telling developers to build AI. You say, oh, wow, what is AI? I say, well, AI is AI. Right? AI means, right, me building machine learning models, or more specifically deep learning models, in this case, to be able to classify images, and then being able to train them and run them at massive scale in the cloud. He said, oh, wow, Daddy, cloud, is that when you take an airplane? I say, oh, yeah, I did, right. Just when I was traveling to China in February, I literally trained a deep learning model running on my machine in the cloud. But that is not all, right? And he said, well, why don't you show me how to do AI? And I have a problem, right? And this is part of his Lego collection that he's collected over the years. I'm sure many of the parents in this room, you have a similar experience, right? Where you get to a point where you have your minifigures from all this collection, whether it's a party series, whether it's a Ninjago series, or whether it's a superhero series, and you just want to be able to use that as a way, right? And being able to classify them really rapidly. And that's when AI comes in, right? So we're going to build a deep learning model, train it in the cloud using GPUs, bring down the model, and then consume this in a .NET application, right, in just about 8 minutes. And we'll see whether it happens, right? So let's get back to the screen here. And let me just close this. Let me just close the conference body just to make sure we are good. Let me close this beautiful tool. Now, what I'm going to do next is the following. I'm going to start a timer. And let's just reset the timer. Time has started. 8 minutes, right? Let's try. Now, first of all, what I'm going to do is I'm going to go to a service called Custom Vision. Now, if you go customvision.ai, you'll be able to come to this service, right? And we're going to start building a machine learning model or deep learning model, right, to be able to classify between Ninjago and superheroes. Let me show you how to do that. Oh, the clock is ticking. Now let me just refresh. And let me start a new project, and I'm saying, hey, this is my pet project or my litter project with sun, Lego. And what I'm going to do next is I'm going to select a project type. For this specific demo, I'm just going to say it's classification. And I'm just going to say this is a general model. You can select different kind of domain. And let me try to click Create Project. Now, what is happening in the background right now is it's creating a project. It's an empty project. I'm going to start teaching custom vision to be able to understand the difference between a superhero minifigure and a Ninjago minifigure, right? So let's do that. Add image, browse local files. Let me look at my Lego images here. Ninjago. I'm going to select a few. Now, as some of you know, this is Sensei Wu. For those that do not know, ask your kid at home, right? And I'm just going to say that this is Ninjago. And I'm just going to upload 9 files. Right now, what I'm doing is I'm telling the machine that anytime you see something that looks like this is a Ninjago figure, right? And it turns out that the Ninjago series, right, has this thing on the face, right, and it has something like a mask, right? Now, I'm going to continue adding images. And this time around, I'm going to teach it to recognize superheroes. In this case, I'm going to choose the different version of Batman, Captain America. And for those that collect this series, you know that it has evolved over the years, right? There's different versions of Batman, whether it's space Batman versus underwater Batman, all kinds of Batman, really fun, right? And we're going to do different versions of Flash, different versions of Spider-Man, right? And maybe one Superman. So once I'm done with this, I'm just going to say that this is superheroes. And I'm going to upload 10 files. That's it, right? I have just uploaded a few files, some of Ninjago, some of superheroes up, and I'm going to click Train. Now, what is happening right now in the background is all these images go to the cloud, right? Using clusters of GPU is training this new model that's going to recognize between Ninjago as well as superheroes. And after a while, it should come back. Now, and of course, it's going to tell you some metrics about the accuracy of the model. I can do a quick test. And in this case, I'm going to browse to a folder that says test. And let's see whether it recognizes Sensei Wu. Awesome, right? It says Sensei Wu is from Ninjago. Everything is great. Let's take a look at the time. It's 3 minutes, right? We still have time, 5 more minutes, right? Now, one of the interesting things here is at this point, I could go to my prediction URL, and if you're writing any kind of application, whether it's a Node.js, whether it is a web application, or whether it's a Java, .NET, any kind of application that speaks REST, you will be able to invoke this endpoint, and now your application suddenly becomes infused with AI, right? But we say, well, that is not exciting enough, right? If I'm going to build a Ninjago versus superhero model, and I'm going to do it with my son, you really want to push it to a Raspberry Pi or a Windows machine, right? And this is exactly what I'm going to do. I'm going to click Export. And one of the things you'll realize is that you will now be able to export into iOS if you're building iOS application, right? And if you export this core ML model and you drop it into your Xcode, immediately it is going to recognize what are the inputs and the outputs, right? Similarly, if you drop it into an Android application, you'll get the same kind of effect as well. But today, we're going to export this as an Onix model, right? And if I click Export right now, what is happening is it's generating the file, right? But not only that, it's taking the huge model that's built in the cloud, compressing it into a small model called an Onix model, and it's going to run on device. So if I click Download, and if I do Save As, and let me just save anywhere on the desktop, and let me just call this a Lego model. Right. This is essentially the model that we have just trained in the cloud, and it should just work, right? Now, once this is done, of course, I could always go to view what the model looks like, and therefore I could use something called the Neutron Browser. I could open the model, right? I could go to my desktop, and I can take a look at the Lego model, and you see that deep inside this model, if I were to zoom in, right, you'll see that this has some image scaler, it does some batch normalization, it does some convolution, it has an activation function, which deep learning folks will see as called ReLU, right? And of course, if you go up and down, you eventually get to a point where it has an output, right? And this is a really, really small model, right? And finally, you should see the output somewhere below, right? Now, and this allows you to see and peer into the insides of the model. But for all of us in this room, we don't really care about what is inside the model, right? We care about consuming the results of the model. And therefore, one of the things that we did is let's use and build an application, right? In this case, what you're seeing here is an application that we have built, and I'll share with you the link later on, called Windows ML Explorer. And one of the things, if you download the latest version or you update your version of Windows, you will now, as a .NET developer, be able to use this thing called Windows ML. And using .NET code, you will now be able to build an intelligent application. And this is what I'm going to do. So what you see here is just Visual Studio 2017 preview. And therefore, what I'm going to do is I'm going to go to this place called ML Models. There's a few things here. But I'm just going to right-click, I'm just going to say Add Existing Item. Now, what I'm going to do right now is I'm going to go to my C drive. I'm going to go to Source, my model, and I'm going to import that Onix model that I have downloaded, right? Now, observe what happened, and this is going to be really fast. When you click Add, it says a file, OK, I'm going to overwrite it. Now, what you're going to see here is immediately on the right-hand side, you see that the Lego model, the Onix file, is added. But because this is an Onix model, and because you're using the latest version of Visual Studio, right, it generates the code that you need in order to work with this model, which is amazing. And if you look at this, this is going to say, this particular model expects or outputs a Ninjago or a superhero. It has a method called create Lego model. And it has a method called evaluate asynchronously. And that's it. That's all you need in order to consume this model. And therefore, if I were to get back to my main view, and I were to uncomment this line called new Lego model, that's all I need in order to consume the output of the Onix model that we have just trained some minutes ago. And let's just run this. And as this is compiling, let's just take a look at the time, 8 minutes. We overshot a little bit, right? If only I'm a superhero and can pause time. Come on. This is going to get started. The Windows ML Explorer is going to get started. And right now, what I'm going to do is I'm just going to choose the Lego detection model. I'm going to select Superman. And it says superhero. Awesome. Right? Now, and right now, what is very interesting here is because this is running on device, I can really run it even on a real-time manner. Right? So let's see whether it allows me to recognize me. And it says I'm a superhero. Right? Now, and of course, how long did we take? We overshot by 1 minute. Apologies. Right? Now, but what you've just seen is the ability to work with your son or your daughter, right, and build a superhero model just like that. Every one of us in this room, by the time you leave this room, you should be able to go customvision.ai and just build the model. Now, the code is going to be available. It's going to be in the resource slide. But this is essentially how the architecture looks like. And with that, I'm going to hand it over to Seth, right, who is going to show you AI can draw.
I'm on one. How's everybody doing? Good. I brought my device.
Here we go. Okay, so everyone can hear me all the way in the back, right? Okay, so I'm just going to keep talking. So imagine though, because usually when we make these models, right, with neural networks and there's numbers in them and we take the covers off, they generally do something like predict yes or no. And you saw that right here, right? A superhero or Ninjago. But now imagine a scenario where you can actually build multiple models that actually fight against each other. And one of the models is designed to generate something. So imagine there's something called a generative adversarial network. I don't know if you've heard about it. You've heard of neural networks. You've heard of convolutional neural networks. Imagine a network that you train to generate an image, let's say of a bird. And then you build another neural network or another network that looks at that bird and says if that's fake or not. That's a fake bird or not a fake bird, right? So now you have a neural network that generates an image, and you have another one that says that's fake or not. And then what you do is you put them in a room together, and you have them fight one another. Right? They just fight. This one generates a picture, this one's like, that's fake. And then it learns like how it figured out that it was fake. And then it goes back and says, I'm gonna update my little numbers in my network. And then it generates another one, it's like, kind of fake. Oh, okay, wait, okay, let me see what you learn. And then you just have that go back and forth, okay? Researchers at MSR in deep learning created a model that did this. But not only did they do that, they actually used as input a description of a bird, and they trained an AI to generate an image for the bird. And they trained another one to see if it's fake or not. But then what they did is they trained an AI in an intermediate step, and I'll show you an image here so you can get a sense for what it looks like. Then they trained an AI with intermediate steps that map the words to specific regions of the image so that the AI can be like, you need to fix this, you need to fix this. And so as it went, the image got progressively better. Imagine that. Now again, my part of the talk is more aspirational to show you the kind of things that you can do with AI. So what I'm going to do is I'm going to bring up this thing called a drawing bot, and we're going to describe a random bird. We're just going to describe a bird. And then what it's going to do is it's going to take the text, and based upon the fight that they had the other day, the one that learned how to draw really good birds to trick the other AI is going to draw a bird pixel by pixel and render it. Okay, it's not like looking something up in Bing. It's generating every single pixel of the image based upon bird images that it got. So I'm going to describe a bird. Let me just use this thing right here as the default. And I'm going to hit create. So the bird has wings that are blue and a red belly. Now you're going to see that like, whoa, computer. But when you squint, right, this is like they only fought for so long. When you squint, you're like, those actually look like real birds, right? Now let me go and show you that this is not fake, right? I'm going to change red to white. I'm going to make it have a short beak and a short beak. If I click create again on the same thing, it's going to be a different bird every time. How does it do that? I didn't do the research, but my job was to take the actual research. Because remember what happened is anytime you build a machine learning model, there's an output. There's a thing, right? He downloaded the Onix model. This one uses the PTH files, which is PyTorch. And there's two, right? There's one that takes the text and maps it to where the image is, and it uses that. And there's another neural network that uses it to generate the image. So two of them together. So let me show you what that code actually looks like. It looks a little confusing because it is, right? I'm a machine learning guy, but not as smart as the MSR researchers. But I do know how to load a model, and I do know how to actually execute it, okay? So let me show you what that code looks like. This is the main thing. I made it into a web service that you can call. Notice that when you call this particular endpoint, create birds, it calls this generate, and it takes all the models, the captions, the word indexes, and all this other stuff. The text encoder and the net, these are the two models that I loaded. And it uses that to generate the images and push it to a blob service. Okay? What does the eval function look like? Here is the actual code that generates the image. And it's crazy, right? Because this guy, I mean, the researchers were pretty amazing at generating this model. So all I did is I loaded it up, and I use them to actually generate the thing. So I get the captions, and I get the caption lengths. I check, for example, if there's a GPU available, and then I go through, generate the mappings from the words to the actual text, or the words to the actual image, and then I generate the export. That's it. Like, I'm literally just calling it, generating it out. Now, here's the thing. I'm going to run this now so you can see it actually running. The sad thing about this is that it was actually written in PyTorch 2, which doesn't work on Windows, PyTorch 0.2, which doesn't work on Windows. So what do I do? Well, all you do is you put the model in a container and run it there. So what you see me just did is I ran a container, and now I can actually call the local version of it and post. And in the body, what I do is I tell it like what, here, this is too small. In the body, I tell it exactly what I want the caption to be. So I'm going to hit send. And let's see what happens. Where's the output go? Oh, there it is. Oh, well, that took 7 seconds. That's not good, right? You can see it did some stuff here. I can post again and go back over here. Notice that it's taken its time. And again, it took 7 seconds. But when I did it the first time on the website, it looked really fast, right? So the next step is like, okay, I got this to work on a CPU. Now I got to get this to work on a GPU. But Seth, you made it in a container. Well, that's nice, because what happens is, because it's in a container, I can put this thing on Azure into a GPU clustered Kubernetes cluster with containers that have GPUs in them, right? And so now, because I was able to containerize it, now you're starting to see like, hey, I can get a model, I can wrap it into a container, and then I can take that container and deploy it anywhere. You can see I'm using Azure Container Registry to save the actual model. And in the Azure Container Registry, I actually have a CPU version and a GPU version. Oh, it opened it. Let me show you that. Right here, you can see that here's my, hold on, it's loading. I should have wired in, but I'm using the, oh, I am wired in. Oh, why is it so slow? Okay, so then I go to the attention, and you can see I have the initial version, a CPU, and a GPU version. And then all I need to do is dump this into a Kubernetes cluster. And this Kubernetes cluster has all of those GPUs running. 2 VMs that have 4 GPUs each in them, and we created like 8 to 12 pods. I don't remember how many there were. And so now when I run it on the actual good one, and I hit a request, send, give it a second. I wasn't kidding. It's a lot faster, right? That had to wake it up. I think it had to be woken up. And now my joke of give it a second, it's a lot funnier, yeah? No? And it's really fast. And so whenever you go and think about AI, here's, by the way, the drawing bot. I can change it to anything. Let me change this to yellow. Now it's calling a Kubernetes cluster with containers that call into GPUs to generate novel images. Now, what does this mean for you? Why is this even important? Think of creative scenarios, but you're working on where you can have AI supplemented things. Right? Or think of other scenarios where you can train neural networks to actually look at images and specify problems that you might have. Or maybe even you're writing some text and think of a spell check on steroids where you train the spell checker to think like Mark Twain. Right? And now it can actually look at your text and say, oh, right here, he would say it this way. Right? With AI, there's a ton of things you can do now, not just with discriminating between different things, but also with actually generating creative things. And that's my tiny little demo. It's actually really fun. You should go to drawingbot.azurewebsites.net, and you can actually try it out yourself. Thank you very much.
Check. Can you hear me? Yeah, cool. Just a second, thank you. So this is on and I've got 7, which is just a quick second, guys. This was 6. Can you just check 6 quickly? Sweet, and then you are on the sweet, and then this one was
Okay, 7.
all right, cool. So yeah, I've been hearing some great news about the announcements since morning. As you know, the message we want to be really landing this build was intelligent cloud and intelligent edge. And before jumping into the demo, I just want to call out which just showed you the drawing board. That's one of the many Microsoft AI innovations we have been trying to put together. And if you were in Harry Shrem's session, you would have heard about ailab.microsoft.com. You can actually go there, learn more about the source code we have provided to you with. You can launch the experiment, play with it, play with the demo, and also get all the links to the MSR AI research papers plus AI School. All right. So in this session, what I'm going to be doing here is I'm going to take you through this whole concept of intelligent edge. Now, you know, Weihong showed you how you can pull in a model like an Onix model and it generates a C# code. And I'll just take that a little bit beyond and deploy certain of these images, ImageNet classifications, or certain models into edge devices. Won't take too long. I know it's a long day for you guys, so I'll try to just make it very quick, and then we can just go for the rest of the sessions. To do that, first I want to explain what that is, a quick look into this. So what we're going to do here is what we did to do this whole chest X-ray analysis was we took this data set from National Institute of Health chest X-ray data, which was trained on the 112, 120 images in general. And the idea was that there was no code associated with it. So we had the model, or we just had to train the model further beyond on the images, but there was no source code that you could build an application. Now, this is how you infuse AI into your apps. So we took that. We have this phenomenal plethora of tools which we use today in Microsoft, especially around Visual Studio tools for AI, where you can do entire data scientist as well as developer work out of a single platform. Now, as you could see, and I'm not going to go deeper into the model because that's something that the data scientist needs to do, I'm more concerned about just getting the Onix model and then just play up my code. So what you would see in this demo is I'm going to show you how you're going to go and use that small little device right there on the right-hand side called IoT Edge Device Minoboard. Right? And this is a 64-bit operating system, and we have deployed a Docker image. So in this particular demo, I'll take you through the entire flow that how we deploy this over IoT Edge. How do we use our DevOps cycles in terms of building my definitions and release cycles, and also show you a real-time inferencing of an X-ray image from that Minoboard. Thing which Joseph Sirosh, I mean, we were doing this in one of the events where I liked what he just mentioned. I want to reiterate. Think about when you have Doctors Without Borders and you have to go to a remote location where you don't have internet. These devices can be a lifesaver. For example, in this particular example, when you take up that chest X-ray image, what we're going to do is we're going to go and put that as an input. Certainly, that's the input for you, and score against 14 top diseases possible looking at that X-ray, right? And then out of that, we'll tell you the top 3, which is the most possible likely cases with that particular chest X-ray analysis. Pretty powerful. Now, so maybe in the next session, if you're going for Eric Boyd's session, you would see this entire thing coming out of Visual Studio Tools for AI, and they might show you all these different edge devices where you can deploy CoreML and iOS device itself, or maybe an Android using TensorFlow. But for this particular session, let me jump in and show you this IoT Edge device, which is super awesome. And I've got this here running, so I just can't move it much. If you guys could see, it's in the case. It's here, and it's a surprise. It's in the case, it's running, and then eventually I'm just going to go and move into this guy and show you that this is running a Docker image, which is running certainly Ubuntu, and I'm going to go and show you the web app we have built, which is running within it. So let me just go switch to 6. I think that should be the right one. So that's basically what my Ubuntu machine looks like with the Firefox. Now what I have here is I can import an image. So per se, you are in this remote location and this edge device. Now you just connected it. It's running locally. Everything is running locally. We have Dockerized the app. We have Dockerized the IoT edge. We Dockerized the entire container, so which is running the model. Now, if I come over here, I could do two things. One, certainly I can just go and click on this guy right here and import an existing image. So if there's an X-ray which is already there in the system, I could just pull that and do a real-time inferencing, and I could do that right away. But what is more exciting is that I have taken this X-ray and I've been provided one with, because there are almost 126 radiologists in the Hospital of Boston, but there's only 2 in Liberia. It's a big, big, big issue to solve. All right. So how do we make or kind of activate radiologists to do more with AI? Augmenting intelligence in general. So let me take this as an opportunity to show you a real-time inferencing on a chest X-ray. All right, so let's see how it goes. So I'm going to click on camera, and certainly it's going to ask me to allow this guy. That's not the X-ray, certainly. And here you go, right? So can someone just hold this for me? Sorry, there's very limited space here. And I want to make sure that that's your X-ray. You come over here. All right, just stand right there. I hope I get a good picture.
It's scary, getting my X-ray taken.
OK, so we're just going to go, and this is all happening on the edge device. Even if I'm disconnected, doesn't matter. So I'm going to capture this. I think I'm good with this. And I'm going to click on Done. It takes a bit of a while. Certainly, it's not running on GPUs. And as you know, this is a deep neural network, which has a pretty complex model associated with it. Give it a bit of a moment. It should come up with the analysis. And remember, I'm running all of this locally. This is not connected to the internet. So wherever you are, like in any remote location or a radiologist, he can actually see this. And there you go. Right? I'm able to go analyze a chest X-ray right by using real-time inferencing on chest X-rays and giving you the results. And as you can see here, it says there's a high chance that I have VHONG has pulmonary infiltration. And also, it's a more likelihood of some of the other diseases. It is sort of 1, 2, 3, as in 1 input and maximum of 3 outputs in terms of top 3 diseases possible. But as I said, we trained it under 14 different diseases possible with each X-ray. Now, this is lovely, isn't it? Solving problems which are really, really deep in terms of healthcare. But just mind you again, we're not trying to sell a device. We're not trying to say that our devices are approved for doing this. We're talking about purely augmenting intelligence in its true sense, right? OK, now that you know about this, let me just go back and show you the entire source code which is running and powering this application to run in the Docker containers within these edge devices. So thank you so much, Rian. All right, so let me first show you the code, and then just reiterate on what VHONG said. And I think we all have been talking about Onix. This is an Onix model as well, converted. Now, here is my entire source code. So I can just go and, my bad. So this is where? Oh, where did I keep it? Oh, that's fine. I can actually go through this. So I can actually go and click on this Microsoft Chest X-ray inference, where basically we're running all of this. And then what we have done here is we have all of this Onix model being pulled into and then converted that into a C# code. Now, what you would see generally is there's all of this inference testing, which we have done as well on the same class. But the best part, which I love about using something like this, is if you right-click, you can actually now export a model as a NuGet package. So the best part is now you can use that as a class on any library and eventually use that to kind of build your applications, nothing like it. I think that is an extension to what you were saying, that great, we have the Onix model, we pull it, we generate the C# code, which you have already seen. But we are telling you today that you also have an option to export that model as a NuGet package. Wow, beautiful. Now let me show you what that looks like, right? So if I expand my references, I should actually go to the test references so that you can see this. This is exactly what I'm talking about. So we kind of went and just right-clicked and exported the NuGet package. Now this is just a class. Now for showing this how it works, I created a predictor test. So if I could come over here, I'm just using that same predictor class to kind of go and wrap around my libraries, and we're good to go. As simple as that, right? It's a very quick way of doing this, and I'm not reiterating on much because you have already seen how you pull in a model and you generate the C# code, which is super powerful. OK, now this is good, right? But then it's good to build the application on a GPU-based machine running locally, good for training and whatnot. But as I mentioned, this device was something which was powered by IoT Edge. Now, why that is important? Because you need to ensure that the models are available to your device and they are being consumed, and then the device is registered to kind of inference the real time. So now what I'm going to do here is I'm going to show you the Azure portal and show you how that IoT Edge devices are actually hosted out of that. That's super critical. So the second step here is let me come over here and show you the entire Just X-Ray IoT Hub Edge. Let's click on that. And then once this pops up, you can just go to IoT devices. And you would see that this device is now connected, and then we are good to go, hopefully. That will show up. And if it doesn't, I can always click on the preview. I hope it just pops up here. OK, cool. So now I could see that I have a connected client, which is currently the Minnow board, which is connected to this Just X-Ray IoT Edge device, which is cool. I can click on it, know more about this, but that's just to kind of ensure that you understand how IoT Edge devices helps you to deploy these models to IoT Edge in general. Now, once I'm here, I can also see there are certain deployed modules, and that's super critical when we talk about IoT Edge. In this scenario, we have a Just X-Ray module, which I can click on, which is deployed to this particular Minnow board. I can go further, and I can check where am I pulling all these images from, or where am I storing this. Now, for this particular scenario, we are storing this all in Just X-Ray CR, which is my container registry, azure-cr.io. So let's have a look at that. How is that powering this entire image analysis? So if I go back to my Just X-Ray source group, I can actually come over here and go to, I can't see this properly. That's the container registry. Now, once I go over there, I can actually now see my repositories, which you just saw how Seth was talking about how he was generating the images. Now, once I come over here, I could see different repositories, and one of them is certainly which is powering all of this on the edge device. So let's just hope it comes up. It does. So this is the one for the web, right? And then this is the one for the Just X-Ray in general. So I can click on this guy, and then it'll show me all the different image and with its tags and everything else. So that's how you could pull up an image and analyze it in real time using IoT Edge. Brilliant. So we talked about doing inferencing on the edge. We talked about why IoT Edge will help you with deploying this to a specific device and just keep it all connected. But what's more important for a developer is what if the model changes? How do I have a continuous deployment of the model? So I'm going to quickly show you what's my build release looks like in general, right? So let me show you the build definitions and also the releases. So if I come over here, what we have done here is we have this, as I said, this was a Docker container which was deployed. So I'm just looking at my build definitions. If I go to Just X-Ray Docker, which is right here, and now I can just click on edit. You would see that this was, sorry, I looked at release definition, my bad. So I should just go to the build definitions. Let me just go to the build definitions first. So that's my Just X-Ray Docker. And then once I come over here, what you would see is, certainly I've been deploying this for some time, and then whenever my model changes, I want this to trigger and automatically create this pipeline, right? So I click on edit, and then what you would see here is that this entire process in the build definition is going to create a Docker image, push the image to the container, generate some artifacts, and then publish the artifacts. So that's a process for my build definition. Now, if I click on triggers, which is super important for our scenario, and that's where I have included and ensured that this particular guy should kick off the process whenever there's a change in my Onix model. Super critical. So in that sense, I don't even have to touch this anymore. Every time there's a change in the model, it'll trigger the DevOps cycle, deploy that to the IoT Edge, and any device connected to the IoT Edge will get the updated model. Brilliant. Great cycle. Now that you know about this part, let me just go and show you the release cycle. In the release cycle, what we're doing here is we are looking at the Just X-Ray Docker, and as you could say, it's deploying through the IoT Edge, and then eventually just going and committing those changes. So overall, what's very important to note is this is an intelligent edge story. Taken with an example of healthcare, but you could think about any application which is powering any of the image analysis, per se, a circuit board, or whatever Vihong just showed you with the superhero, right? You could use custom vision to do certain model development, but you can also do some custom model development at the level of DenseNet and, deep neural networks, and using some of the frameworks of TensorFlow, CoreML, or Onix, which is open framework, and then deploy this to the edge. Now, on that note, I would like to show you the AI lab, which we are super proud of working on. We have been working on this for the last 15 days tirelessly to release it. And there's a lot of work which has gone behind it. So you could try a lot more of these. And if you click on the projects, basically the one which just Seth mentioned about DrawingBot, you can just click on this and you will see more details. Because of my screen resolution, this looks a little weird. But generally, what you would see is you can launch the experiment. So you all can go there, land up in the DrawingBot, draw your birds, post about it, and let us know how you feel. Similarly, you can actually go and look at the GitHub, where the whole source code is, and some more details in general as a video. Similarly, some more. So we currently hosted 5 top experiments, which we think is great. Like JFK files, a great example of cognitive search and how we're building custom skills, extracting knowledge out of the data set which we have, whether videos, images, or whatever, and then making sense out of it. So you could see all of that. This is a great scenario. And then similarly, you have style transfer, which is another great example of how you can use image analysis with using some of these open framework and models. All right. That's pretty much from my side. If there is anything else you want to talk about, great. Well, we're happy to go and take some questions otherwise.
Thank you. So this slide will give you all the resources you need for whether it's Windows ML Explorer, AI Lab, and Conference Buddy. Now, all the code is available. We welcome everyone to join us as well as evolve the code further. And last but not least, thank you from the AI folks. Thank you, everyone, for attending this session. We deeply appreciate your time. Thank you.
Thank you.
Yeah, we can take 2 questions. 1 question behind. Sure.
Yes, sir.
So the question is, when you use video indexer, which is shown earlier, what do you extract or what do you match, right? So when a video is uploaded to video indexer, we actually run it through both video processing pipelines as well as audio processing pipelines. So if there's image on the screen, it's going to do OCR. If there's audio, it's going to do speech to text, right? And then in real time, we're going to index it as well. And once this is all done, you can immediately search for it and get to the point of the video where it happens. Yeah. Thank you. Thanks a lot, everyone.
Cool.
Thank you for your time. Thank you.